also look at a few calculations on weight. So we have an example here. Remember, first of all, we said that weight is equals to mass of the object times the gravitational force. So we have an example here, a reading. Calculate the weight of a car of mass 500 gram. Into bracket, take G is equals to 10 Newton per kilogram. Now G, this one represents the gravity on Earth. So they want us to find the weight. So we said that weight of a body is equals to mass of the body times the gravitational pull. Now we have the mass of the body, which is 500 gram. But remember, for us to find the weight, we need to express all quantities in their SI units. So we said that the SI unit for mass is actually kilogram. So that means we have to convert 500 grams into kilogram first. So we know that 1,000 grams is equals to 1 kilogram. 1,000 grams is equals to 1 kilogram. What about 500 grams? So this will be, we divide with units with the same unit so that they cancel out. So divide by 1,000 grams times 1 kilogram. So grams and grams cancel out so that we remain with our answer being 2 zeros and 2 zeros cancel out. 5 divided by 10, we actually get 0.5 kilogram. 0.5 kilogram. Now we have our mass. We are also given a gravity. So remember, when a unit is written Newton kilogram power negative 1, this one simply means Newton per kilogram. So weight will be equal to mass times gravity. The mass is 0.5 kilogram times gravity is 10 Newton per kilogram. This one can also be written this way, Newton per kilogram. Newton per kilogram. So actually our weight will be equal to 0.5 times 10, you get 5 Newton. How are we getting the Newton? Because here we are multiplying actually the kilogram times Newton per kilogram. Remember, per means division. Therefore, the kilogram and the kilogram will cancel out so that you remain with the Newton. That's why we are saying that the weight will be 5 Newton. We look at another example here which reads, an astronaut weighs 300 Newton on Earth. So this is the weight of that person on Earth, W Earth. So W Earth is actually equal to 300 Newton. 300 Newton. On Jupiter, he weighs 150 Newton. Calculate the Jupiter gravitational strength. So remember, to find the gravitational strength from the formula of weight is equals to mass times gravity, we need to have the weight of that person on Jupiter and also the mass of that person on Jupiter. So the mass on Earth will actually help us to find the mass of that person on Jupiter. So remember that from weight is equals to mass times gravity. So this one means that actually the mass will be given by weight over gravity. So the mass of that person on Earth will be equal to weight of that person on planet Earth divided by the gravitational force or gravitational field strength on Earth. So weight of the person on Earth, an astronaut weighs 300 Newton on Earth. So it is actually 300 Newton. Divided by gravity on Earth. Take G. This is always the gravity on Earth. It is actually 10 Newton per kilogram. So here we have the mass of that person on Earth being equal to 0 and 0 will cancel out. So this will be actually be 30. So this is mass, so it will be kilogram. Kilogram, because here we are dividing actually, be careful with these units, we are dividing Newton divided by Newton over kilogram. So this is Newton times the reciprocal, kilogram over Newton. So Newton and Newton cancel out so that you remain with kilogram as your answer. Now remember, we said that mass is also constant everywhere. So it means the mass of that particular astronaut on planet Jupiter is the same as the mass of that person on Earth, which is equals to 30 kilogram. The reason is because mass is constant everywhere. Mass is constant everywhere. So if we have the mass of the person, so if we need the weight, remember the question wants us to find the gravitational field strength. So weight is equals to mg. So it means if we want the gravitational field strength of that person on Jupiter, that is G on Jupiter, actually will be equal to, so if I divide both sides by m, so I'll have W that is on Jupiter, W Jupiter over mass on Jupiter, so that we have the gravity on Jupiter. The gravity on Jupiter will be equal to weight of the person on Jupiter. So we have been told that on Jupiter he weighs 150 Newton. So the weight on Jupiter is actually 150 Newton divided by the mass on Jupiter. Remember, we have said that mass is constant. So mass on Earth is equals to mass on Jupiter, which is equals to 30 kilograms. So this will be equal to, actually the 0 and 0 will cancel out. 3 here, 1, 3 into 15, 5. So this will be equal to 5 Newton per kilogram. 5 Newton per kilogram. Sometimes we can also write it as 5 Newton per kilogram. Per can be represented by -1. So having understood those two examples, there is also an exercise here which I recommend that students should try. So in case it is not clear, I'm going to read it here for you. So the first exercise reads, calculate the mass of a body which weighs 75 Newton on Earth, full stop. Into bracket, take G is equals to 10 Newton per kilogram. So I've actually worked out and found the answer as 7.5 kilograms. So try working out and see whether you get the same. Exercise 2 is that a physicist weighs 1000 Newton on Earth, full stop. On planet Mars, she weighs 500 Newton, full stop. Calculate the gravitational strength on planet Mars. So the answer actually I've worked out and found that the answer is 5 Newton per kilogram. Of course, remember that gravity on Earth is 10 Newton per kilogram. So so you can also look at what we call the resultant force. Now remember, resultant force, this is actually the sum of forces in a given direction, That is, if you want to find the resultant vectors, we will actually take the sum of the vectors in the right hand side, then sum of the vectors in the left hand side, then we sum them, of course putting into consideration the aspect of direction, So we can just conclude here that if two vectors are parallel to each other, and moving in the same direction, we add them to find their resultant vector. Conversely, if two vectors or forces are parallel but moving in opposite directions, we subtract or minus, them to find the resultant force, resultant vector or force. So we have an example here. We are required to find the resultant force acting on each of the following bodies. So in part A, we are actually given some of the forces on the right hand side. So we can talk of some of the forces on the right hand side. So right hand side is actually this one. So we have 4 Newton plus 2 Newton. So actually that comes to 6 Newton. Then forces on the left hand side, we only have one force, which is 3 Newton. But because 3 Newton is moving in the opposite direction with the 4 Newton and 2 Newton, it means the resultant force or the resultant vector acting on that will be force on the right hand side minus force on the left hand side. So I've begun with the right hand side because I'm assuming the right hand side is actually representing my positive direction. So this will be the force on the right hand side minus force on the left hand side. F right hand side minus F left hand side, which is equals to 6 Newton minus 3 Newtons, which will be equal to 3 Newtons. So that is the resultant force for part A. For part B, we actually have the forces on the right hand side. So we only have two forces. We have the 4 Newton force and 7 Newton force. So this will be equal to 4 plus 7, you actually get 11 Newton. Forces on the left hand side will be, we have 5 Newton and 6 Newton. So 6 Newton plus 5 Newton. So that will be equal to actually 11 Newton. Then the resultant force, that is F resultant force, so this will be equal to force on the right hand side minus on the left hand side, because they are all equal. So even if you began with the left hand side minus right hand side, the answer will still be the same. So this will be forces on the right minus forces on the left, which is equals to 11 Newton minus 11 Newton, which is equals to 0, which is equals to 0. So the resultant force acting on these bodies will actually be 0. So a student, you can find a student recording 0 Newton. Actually, the answer can just be 0. It is not a must that you record the units. But if the answer is something like 3 or 1 or 4, actually, you must indicate the units. So you also remember the aspect of direction. So we are saying minus because the forces are actually moving in opposite direction, just like this example up here. So the force 3 Newton is actually negative 3 Newton because it is moving in the opposite direction to our the forces in the right hand side. So there is also an exercise here that I recommend students should try. Question 1 actually reads, find the resultant force acting on each of the following bodies. So body A here, on the right hand side we have 2 Newton, 5 Newton and 9 Newton. On the left hand side we have 6 Newton. So the expected answer is actually 10 Newton. So try out and see whether you get that. B, we have 8 Newton on the right hand side, 2 Newton on the left hand side, 6 Newton on the left hand side. So the expected resultant force is actually 0. Thank you.